Hey guys, finally starting chapter 2. We just finished chapter 1, started chapter 2. So chapter 2 is going to be organizing and summarizing the data. So chapter 1 was all about the data collection, us going out and getting raw data or getting material to organize. This chapter is going to be organizing it into a couple of different ways. All right, specifically, this one is going to be organizing qualitative data. So remember, qualitative versus quantitative. Qualitative, we're looking at the qualities. So this is going to be like colors or different categories that do not involve any sort of measurement. So let's get started. Okay, so when data is collected from a survey or designed experiment, they must be organized into a manageable form. Data that is not organized is referred to as raw data. And step 1, qualitative data and tables. So now we're going to start with a frequency distribution. So frequency distribution lists each category of data and the number of occurrences for each category of the data. So for example, here, let's go ahead and read it. So a physical therapist wants to determine types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records a body part requiring rehabilitation. Choose or construct a frequency distribution of the location of the injury. So if you look at this part right here, so here, if we look at this table, all of this data is really, I'd consider unorganized, and we don't really know exactly what's going on. So I see back, wrist, elbow, back. So what we could do is organize it into a nice little table, and let's see how we could do that over here. Okay, so what I'm going to do is I'm going to list or write down everything as it happens. So the very first thing that I see on this list is back. So we could have a category for back. And let's see how many back we have. How many backs we have? We have 1. Let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 backs. And let's change the color. Let's try blue. So the next one we'll do is going to be wrist. And we have 1. Keep going down, looking for more. We have 2 wrist. So actually, instead of writing the numbers, I'll do tally marks. So 12 tally marks for back. So 12 there. Next, let's try some, let's look at hip. So hip, we have 1 and 2 for hip. Next, we'll do neck. We have 1. And I don't see any more neck. Shoulder. We have 1, 2, 3, 4 for shoulder. Next is going to be elbow. We have 1 for elbow. And it looks like there's only 1 elbow. Next, we'll do knee. We have 1 for knee, 2, 3 for knees, 4, and 5. Hand. We have 1 for hand, 2 for hands, and the last one is going to be groin. And it looks like we only have 1 groin. So now that we have that, let's kind of concentrate a little bit more on this table. So back, let's Just make it a little bit prettier. And we had one for groin. So now that we have that, we have our tally marks or our frequencies. And let's write an actual number associated with these frequencies. So for back, we said we had 12, wrist, we have 2, hip, we have 2, neck, we have 1, shoulder 4, elbow 1, knee 5, hand 2, and groin 1. So now what we could do is add these together just to make sure that we have all of them. Because if you guys remember over here, they did say that there were 30 of them. So there were 30 different, trying to get my marker. So there were 30 different patients. So if we add all these numbers up, it should equal 30. So we have 12 plus 2, that's 14. So 14, 16, 17, 21, 22, 27, 29, and 30. So when we added all those numbers up, we ended up with 30. So we got all of them. So now this here makes a little bit more sense. Now that we have that, let's go ahead and rewrite it. So we have back, wrist, hip, neck, shoulder, elbow, knee, hand, groin. Twelve, 2, 2, 1, 4, 1, 5, 2, and 1. So now organizing a table from this over here, let's go ahead and clear all this stuff out. All the little markings. So now we went from this table over here to the left to something that we could actually study, right? So we could actually see that from here, the majority of the, what was it? The majority of the physical therapist rehabilitations are for the back, and next with not as many is going to be knee, then shoulder. So majority ends up being back. So majority of her patients are seeing her because of back issues. And let's see if we missed anything. So they tallied everything up. Their list is a little bit different than mine. I not messed up, but we kind of organized it a little bit differently. But it's all the exact same information. All right, so now caution, the data in table 2 are still qualitative data, even though the frequency, so the frequency simply represents the count of each category, because we still have to measure something, right? This still is a math class. So even though it looks like it might be quantitative, quantity being a number, it's still going to be qualitative data because of the way that we acquired the information. All right, so now this leads to relative frequency, because all of these numbers are really cool, but how could we actually throw some actual facts in there? So with relative frequency, the relative frequency is the proportion or the percentage, those two words go hand in hand, proportion and percentage, of observations with a category, and is found using the formula frequency divided by the sum of all frequencies. So the relative frequency distribution lists each category of data with the relative frequency. So basically, how does each of these values compare with one another? So let's actually go over here and bring this one back up. And let's organize this and follow the exact same steps that we had just a second ago. So give me just a second. I'm going to write this a little bit smaller, neater, so we could actually work with it. Okay, and we're back. So here we organized it a little bit prettier. I'm actually able to write stuff over here now. Okay, so what we talked about earlier was the relative frequency was the, So the relative frequency, let's just go back to the slide. So relative frequency was the frequency divided by the sum of all frequencies. So remember when we added all of these values up, what we ended up with was, so what we ended up with was 30. So all of these are going to be divided by 30. And we're just looking at the proportion of each of these locations relative to the rest of them. So basically, where do they rank? So with this very first one with back, the total or the frequency for back was 12 and the total frequency was 30. So now the relative frequency for this one is going to be 12 divided by 30. And let's see what that value is. So 12 divided by 30. Okay, back to a calculator that actually works. So the value we're looking for is at 12 divided by 30. And there we go, we got 0.4. So the relative frequency for this part is going to be 0.4, or if we want to find the percentage, just a little recap to find percentages. Percent is parts out of 100. So what we're going to do is multiply this value by 100. For this value times 100, there we go. And that gives us 40, so that would be 40%. So you could do this with any one of your values whenever we're talking about percentages, relative frequencies, proportions, a lot of different values. But the number that we're going to use, at least for this table, is going to just be that 0.4. So now let's look at the frequencies for the rest of these. So 2 divided by 30. 2 divided by 30 gives us 0.0667. So 0.0667. And since that one is also the exact same number, 0.0667, 1 divided by 30. So 1 divided by 30 is 0.0333. And this one is also 1, so this one's also 0.0333. And same thing for this last one. Next is going to be 4. 4 divided by 30 is 0.1333. 5 divided by 30 is 0.1667. And the last one is going to be that 2 divided by 30. 0.0667. So now all of these values, think about it, if we add all these values up, they're going to equal 30. If we divided all those numbers by 30 with the rules of addition, it's going to end up giving us 1. So in reality, if we add all these values up, they should be equal to 1. So just so you guys could see that, let's go ahead and do that. So 0.4 plus 0.0667 plus 0.0667 again, plus 0.0333 plus 0.1333, 0.0333, 0.1667, 0.0667, and lastly 0.0333. And see how they all equal to 1. When we add all of those values, they're always going to give us 1. So that's another rule of that relative frequency. The sum of all of the relative frequencies should be equal to 1. And that'll be useful in chapter, I believe it's chapter 7 or 8, one of those two. But now let's go back to our lesson. And let's see if we missed anything. All right, so we talked about that part. The sum of all the frequencies in the table is 30. And here we have all the frequencies, or all the relative frequencies. So some of them aren't going to be exact, just like you saw in the calculator. They're not going to be exactly those values. So they cut off at the very, very end because they didn't want to put like an infinite number of values. So they chose a place to stop and they stopped there. Kind of like we rounded up to 4 decimal places. They did the same thing. All right, so from the distribution, the most common body part for rehabilitation is back. So we saw that again over here. So we saw that over here when we had 0.4. If you guys want to have these values kind of represented, you would say like 0.4000, just to give you that 4 decimal places. So 4 is the greatest number out of all of them, or we could say back is the greatest or most reoccurring body part out of all of them. And there we go. So now constructing bar graphs. So with the same data, we could actually make it look a little bit different because right now we see a bunch of numbers. Some people are more visual. So a bar graph is constructed by labeling each category of data on their horizontal or vertical axis, the frequency or relative frequency of the category on the other axis. So rectangles of equal width are drawn for each category. The height of each rectangle represents the category's frequency or relative frequency. So use the data summarized in table 3 to construct a frequency bar graph and a relative frequency bar graph. So let's come right over here and constructing a frequency bar graph. Again, what we're going to do is organize this into a graph. So we're really going to organize it into 2 graphs. So I'll have 2 separate pages for this. So we'll do a bar graph for the frequency here, and we'll do relative frequency on this page. All right, so let's see. First thing we want to do is have like our axis. So the axis, our vertical axis, is going to come back from this side. Horizontal is going to come off of this side. So vertical axis, what we want to do is build our graphs up this way. So this is like our little playing field. This is our ground right here. There are times where you could have it to the right and build your bar graphs this way. I personally don't like that. It doesn't really it doesn't give us like a good estimation of everything. So vertical is our choice. So here, the next thing we're going to do is locate the highest number. So in this case, it's 12. So we're going to have 12 going along this side. So this is going to be our frequency here. So we'll say this is 2, 4, let me zoom in, 6, 8, 10, 12, 14, and 16. So again, we're not going to need all of those because our highest number is 12, but it is nice to go a little bit above what you're looking for. So we'll go up to 14. So next, what we're going to do is label each of our locations. So all of our data. So we'll start here with back. The next one we'll do is wrist, then hip, neck, shoulder, elbow, knee, hand, and groin. And now all we're going to do is look at whatever the frequency is and match it to the numbers over here on this side. There are, obviously, we don't have a 1 because we did write all even numbers on this side, but 1 is just going to be halfway up. So very first one is going to be 12. And remember, we don't want anything overlapping. So we're going to keep these kind of tight. So this first one being 12. And another thing we could do is write the number 12 right here, so that way we know exactly what it is. So wrist was 2. Hip was 2 as well. Neck was 1, so we're only going to go halfway up on this one. Shoulder was 4. Elbow was 1. Knee was 5, so we're going to go between this 4 and the 6. Hand was 2. And groin was 1. The reason why you sometimes want to write the numbers right above them is because at times you might not see exactly where these numbers fall. This scale was pretty simple, like it was very tight, but there are going to be times where you have like, let's say 0, 100, 200, 300, 400. So looking at those numbers and you go up right here, it doesn't give you an exact value there. So you could say like 213 to be a little bit more exact. Again, here it doesn't really matter. It's not that big of an issue because it's pretty simple to read this graph, but you guys could always get in the habit of that. So this was 4, this was 1, 5, 2, and 1. So this here is a frequency bar graph. So this is the frequency bar graph. The next one we're going to do is going to be relative frequency. So here, all we looked at was the frequency. For the next one, we're going to look at relative frequency. So again, we're going to label everything the exact same way we did last time. Let's see. So I'll do this off camera, just rewrite. Okay, I'm back. So just the same way that we did over here, the largest number we had was 12. Here, I want to give a little bit more dispersion. The largest number we have here is 0.40. So what we're going to do is adjust this so that way we have a little bit more leeway here. So here, 0.40, what I want to do is label, the very bottom is going to be 0, of course. This will be 0.05. We'll say this is 0.1, 10, 0.15, 0.20, 0.25, 0.30, 0.35, 0.40, 0.45. And we could just erase this last one up here. All right, so now that we have those values, we're going to match those horizontal values to the values that we have over here on frequency. So for this very first one back, we're at 0.40. So very similar to what we did last time. We're going to bring this all the way up and all the way back down. And there we go. There's our bar graph. And the next one, or that's our bar for back. The next one is going to be wrist. Wrist is 0. Oh, I see what I did there. Oh, it still did it. Okay, so that's for back. For wrist, we're going up to 0.06. So 0.05 is right there. So we're going to go just above that to 0.06. And that's for wrist. The next one is going to be hip, going up to 0.06 again. Neck this time is going up to 0.03, so right below that line. Next one is neck. Shoulder is going up to 0.13, so just below 0.15. Elbow is going up to 0.03. Knee is going up to 0.16, so just above this right here. Hand is 2.0 or 0.06, so just above that first line. And lastly, groin 0.03, just below that line. Make it look a little bit more rectangular. And perfect. So now, just like we did earlier, we could make these the actual values, so 0.400. This was 0.0667, same thing here. And this one here. Neck was 0.0333, same thing here. And same thing here. Then shoulder 0.1333, knee 0.1667. And one thing to note is that these have very similar structures, and that's because it's the exact same data. This one, we just looked at the relative frequency where they ranked it within each other. Over here was the actual frequency. So the actual frequency or the relative frequency comes from the frequency plot. So these two are going to always be very similar in nature, just a little bit different because the scales over here are not exactly the same. So the values over here are not going to be exactly the same. But the structure is, this one's still the tallest out of all of them, just like it is here, tallest out of all of them here. And we have a tie, three-way tie for the shortest at 1, 2, 3 here, just like we have a three-way tie for the shortest at 1, 2, 3 over here. So the data ends up being pretty much exactly the same here. All right, let's see if we missed anything. So from here, you could see that the relative frequency plot, they're nearly exactly the same. They even drew them a little bit more alike on each other. Just the difference is going to be the stuff over here on the frequency part. So frequency over here is going to be different from the relative frequency over here. The body part is still exactly the same, just like it is right over here. So that ends up giving us all the data that we need there. Caution, graphs that start the scale at some value other than 0 or have bars with unequal widths, bars with different colors, or three-dimensional bars can be misrepresented or can misrepresent the data. So you never want to show anything weird, out of the ordinary, anything that doesn't look natural to what everyone kind of reads as a table. So you don't want to grab anyone's attention and do that. So one way of doing that would be coming over here and like making this one super, super dark. Or you know what, let's do it with the smaller one. So if we look at this value right here, your eye automatically goes to neck, right? So neck ends up being the one that stands out the most, when in reality, elbow and groin are the exact same values of that. So you don't ever want to misrepresent the data. You don't want to show that one data value is like superior to another. So another really good way of doing that is like highlighting this one as being maroon versus the other one as being just a regular natural color. So that data is going to kind of stand out too. It's going to make you think that there's something wrong with hip, there's something different. Again, you never want to misrepresent the data in that way. So use a statistical spreadsheet to construct a frequency or relative frequency bar graph for the data in the previous examples. So let's see. Okay, so what we have here is the data, and I'm going to show you guys how to organize this in a pretty easy way. All right, so the first thing that we're going to do is go over to our table, and we're going to start using Excel to draw everything for us because they always do a little bit of a better job than we do. So let's go to where we had our table. And this is how we're going to get the data and have Excel organize it for us. So Excel over here, we could go to insert and select data from a picture. And we're going to take a picture of this right here. So with your device, I'm not exactly sure how you could screenshot it, but for a MacBook Air or a MacBook in general, you would hit Shift, Command, and 5, and it automatically does this so that way you could take a picture of the data. So I just crop it as much as I can, capture it, and from here go over to Excel, let this kind of save in on my computer. And we're going to take the picture from a file, and we are going to look for it here. So screenshot, open the data. And it might look a little bit weird here just because we have this middle portion here. So everything else looks good. So the back 12, wrist 2, elbow 1. So let's insert the data here. And it has 13 errors, but we're going to insert either way because it didn't read the tally marks here. And from here, what we could just do is delete that column. And now we have this. We have our frequency. We have a body part. Table 2 is what it's called. And now to have the data be drawn for us, we're just going to highlight this and come over here. Remember, we want a bar graph. So bar graph ends up being this very first one here. Cool. And it did everything for us. So notice that back, it labeled it as back. We went over here up to 12. The frequency ended up being 12. Just like we did earlier, they made a second mark over here, or a last mark, so that way we could kind of range everything. And it did everything for us. So now let's do a little bit of fun work. And let's get our relative frequency in here. So here we're going to learn a new command. So we could do almost everything that we're going to need in this class here on Excel. And one of the easy things that we could do is our addition and subtraction. So let's do a little quick demo. So equals any value, I'm going to say 5. And for addition, you're just going to use the plus sign. So 5 plus 3, it should be 8, and it gives us 8. So what about, always hit equal so that way you could do the action. So let's do 3 minus 5. Gives us -2, cool. And now for, that was addition, subtraction, multiplication, the number we're gonna, or the command we're gonna use is the asterisk. So we could do 3 times 12. So shift 8 for that asterisk. So 3 times 4 gives us 12. And there we go. So the last one is going to be division. Let's say 8 divided by, we're going to use a forward slash. So forward slash, we'll divide that by, I don't know, 2. Should be 4. And there we go. So addition, we use the addition sign. Subtraction, we use the minus sign or the tack mark. Multiplication, we use an asterisk. Division, we use a forward slash. So now for relative frequency, remember what we're going to do is add all those values up, and then we divide, or each of these values divided by the total. So what we could do down here is write total, and we'll do it in bold so it kind of differentiates between the rest of them. So total. And in order to find what the total is, we have to add all those up or find the summation of all of them. So equals sum. Sum is going to add all of the values up for us. So sum, and we're going to highlight the values that we want to be added together. So all of those values, hit enter, and it gave us 30. So now the sum is always going to be 30. Some more fun Excel work is going to be always start with equals, and for the relative frequency, all we have to do is this value divided by this number here. So that gave us 0.04. Perfect. That's exactly what we needed it to do. And let's have Excel do this work for us again. So this value divided by this value here. Awesome. So Excel does another really cool thing, because it'd be cool if we could just, like, it's fun doing all of this here, then dividing, hitting enter. But what we could also do is have Excel do all of that work for us. So from here, we could grab this corner and drag it down. And it does show an error, but the reason for that error is because, so like this value, it grabbed B6, so it grabbed this value here and divided by B13 when it should be dividing by B12, right? So B and then 12. So what it did here is it grabbed this value, went down, or it grabbed the original command from here, which was these two values. This one grabbed those two. So what we have to do is kind of freeze this one to be divided by this value all the time. So let's start way up here. A way we could do that is put dollar signs around that B. So putting a dollar sign around that B locks that value into place. So that way, when you drag it down, all the way down, it divides by that number. So this one's being divided by B12. That one's being divided by B12 as well. And it keeps doing that same thing for all of them. So now the only ones that move are this first one that we told to move. So one more time, we're dividing these values here, or this value here, by this number here, the total. And again, we're doing the same thing there. This value here divided by the total. This value here divided by the total. So we froze this one to stay where it was, and we did that over here. All right, so now this chart, remember, this one is our frequency table. So frequency, I'm sorry, not frequency table, frequency bar graph. And now we're going to work on our relative frequency bar graph. So let's hide this. So backspace and then say hide. And that kind of ruined it for this data right here. So let's delete it. And now what we're going to do is find or do the exact same thing and graph our relative frequency this time. So grabbing all this data here, we are going to insert a graph. So coming over here, graph this way, and it did everything for us once again. So all the data that we found over here, or all the data that we accumulated over here, it graphed it for us over here. So let's take a look at HIP. HIP ended up being from right over here, it went up to 0.0667. HIP 0.0667, and they did a really good job of actually getting a lot closer than I did with my graph. But there you go. That's how you could graph these on Excel. Makes everything a lot easier. So let's go back to our original table. Okay, so the next thing we're going to talk about is a Burrito chart. So a Burrito chart is a bar graph where the bars are drawn in decreasing order. So we're going to start with the largest value and then go down from there. So if we were to look at these values here, we could do that. Let's see how we could do this on Excel. So let's clear that. Let's unhide this over here. So relative frequency. So now looking at this here, what we could do is sort. So let's come over here, equals sort by. So we're going to sort this data here by, so comma, array 1. No. There we go, array 2. Oh, we should have put in ascending orders. So let's see. And then ascending or descending. So we'll put -1. There we go. So ascending, and you guys kind of saw what was going on there. Ooh. Okay, there we go. So now that we have this in ascending order, we could do the exact same thing that we did earlier and highlight this. Highlight this, insert recommended graph, and there we go. So doing ascending order automatically put it in order for us. Another way we could have done this is just put these in order. So the very first one was back, then the next one, the next highest one was knee, then shoulder, and then we have a 3-way tie for the next one. So 2, 2, 2, wrist, hip, and hand, and then the other ones are kind of left by themselves. So if you look at this here, what did they do? They did put it, no, they didn't put it in alphabetical order for us. What they did is they just saw whichever one was listed first. So obviously back is going to go first, then knee, and then shoulder with 4, then wrist, hip, hand, wrist, hip, hand. They kind of just grabbed it from the order that it was here. It doesn't matter how you add it on here. We could have had hip, hand, wrist. We could have had neck, groin, elbow. Doesn't matter what those values are. The only thing that really matters is that we descend from here. The highest number is in the very beginning, and the lowest number is going to go all the way down here, which there was a 3-way tie for that lowest. So there we go. And theirs is actually exactly the same as ours. Okay. All right, so next we're going to do side-by-side bar graphs. So suppose we want to know whether more people are finishing college today than in 1990. So we can draw a side-by-side bar graph to compare the data for the 2 different years. Data sets should be compared by using relative frequencies because different sample or population sizes make comparison using frequencies difficult or misleading. So now grabbing this data, again, let's take a snapshot. So for me, it would be Command-Shift-5. And here we could take a picture of this data. I'm going to kind of cut off that bottom part where it says Census Bureau. There we go, capture. And now I'm going to take it over to Excel. Let's work on a new sheet over here. So again, we're going to take the data from that picture. So insert data from picture. And we're going to go over to my snapshots. There we go. And from here, you just want to make sure that the numbers are correct. So we're looking at education and education attainment pool, 1990, 2017. Then we have 39,349, good. 26,852. Good, good, good. There are times where it does add extra spacing that you don't need. Associate's degree, good. Bachelor's degree, good. And then we have the totals. All right, so now that everything looks good, let's go ahead and insert the data. I personally didn't see any problems with it. Ooh, and I messed that up. So let's go ahead and copy and paste it up here. All right, so again, what we're going to do is highlight these values and we'll see. Let's see if there is any problems with totals. All right, looks like it got our data for us. And we could either do that graph or this graph right here. There's a couple of different graphs that we could choose from. Let's go with this one. So here we're able to see it a little bit differently. What they are going to do over here is probably do it vertically, like I said earlier. But here we go. So totals that ended up, you know what, let's maybe cut that one out and just look at this data here. Oh, there's a problem. Insert, and then we want a bar graph. Does this one look better? Yep. And there we go. This is a better representation. So the other one, the totals made it look as if it were like a different category that was way more awesome than the rest. But here we have not a high school graduate, not a high school graduate. So it looks like there were less, or there were more people that didn't graduate high school back in 1990 than there was in 2017. And looking at high school diplomas, there were more considerably. And it looks like everyone is a little bit more educated in 2017 than they were back in 1990. And you could kind of see it here too. So is this a realistic, is it realistic to say that? Is it realistic to say that more people are educated now than there were back then? Or because if I say that, it kind of looks as if we're looking at these relative, or here they're looking at relative frequencies instead of just like the side by side. So relative frequencies might be a little bit different, especially because the population is a lot greater right now than it was back then. So let's look at that next. So let's find the relative frequencies of each of these and see how that compares. So let's copy all of this. So now relative frequency is, let's get a little bit more spacing here. All right, perfect. So relative frequency, remember, is the value divided by the total. So we already have totals right here. Let's highlight that. And let's get the relative frequencies for each of these. So that was educational attainment, 1990 and 2017. So now this value, so equal to this divided by this. Remember, we're going to freeze this cell so that way whenever we drag and drop from here, it's just going to pick up that number. So freezing that cell, we have our $sign there and our $sign there too. So now we could pick this up, drag it all the way down, and let's take a look at this value. So this one comes from some college no degree, some college no degree divided by this value right here. All right, perfect. So now let's do the same thing over here. Equal to this divided by this. Now we're looking at the relative frequency for this column. So from here, we're going to freeze this cell. There we go, much better. And now that we froze that cell, we're going to drag this all the way down. And let's do that one more time. There we go. All right. Now that we have that, let's graph this data. So now looking at this data, are we able to say the exact same thing? Ooh, so maybe not so much. So not a high school graduate. Oh, let's see. So insert by that table. There we go. All right, there we go. So are we able to say the exact same thing now? So relatively speaking, a graduate degree, more people do have graduate degree, or the percentage of people, more percentage of people in 2017 have a graduate degree, more percentage of people have a bachelor's degree. Very, very few, because if we look over here, it looks like way more people have bachelor's degree, way more people have graduate or professional degrees, but in reality, it's not that much. So here we're looking at just the amount of people that are now a little bit more educated than they were back then, but it doesn't really have that great of an impact. So there are more people that are educated, but there's also the fact that there's more people here. The population is a lot greater now, well, not a lot, but it is greater now than it was back in 2000 or 1990, not 2090. So there's more people now, or there were people more wow. There are more people in 2017 than there were in 1990, which means that there are going to be more people with graduate degrees, but it doesn't really match the percentage. So the percentage of people are a little bit more educated here. High school diploma, it actually looks like the percentage, a greater percent were high school graduates, more in 1990 than there were high school graduates in 2017. So this number is not realistic. So you can't say that part. All right, so now that we have that, using the relative frequency does help, especially with stuff like that. All right, so comparing two data sets, part B, make some general conclusions based on the graph. So the relative frequency of adults who are not high school graduates in 2017 is about half that in 1990. So in 2017, a much higher proportion of the adult population has at least a bachelor's degree. However, the proportion of population with a bachelor's degree has not doubled, as the frequency in table 4 might suggest. So yeah, it has not doubled. It just looks a little bit higher right now. So an overall conclusion is that adult Americans are more educated in 2017 than they were in 1990. And you can also think of the people over here too. So here, high school diplomas, once you, like if you don't graduate with your high school diploma, then it looks really bad, right? But they're not counting all the people that got GEDs. So there are going to be more people that have these different graduate degrees, because it's not people that are just getting out of high school too. It's the people that are a little bit older that are getting graduate degrees, which there isn't a problem with that either. So more people are getting a little bit more education right now because it's kind of called for, especially right now. It's a little bit harder to get a job if you don't have a college education. But we'll stop with that. All right, so now horizontal bar graphs, just so we have over here. It doesn't look like we were able to make them, or maybe we could kind of switch it over here. Oh, there we go. Yeah, so we could change it. So this is the way that it would look if it were a horizontal bar graph. Let's do the same thing over here. Change to horizontal. Ah, there we go. Much better. So now we could see everything a little bit, tiny bit better. All right. So horizontal bar graphs, same thing we did earlier. All right, so now constructing pie charts. So a pie chart is a circle divided into sectors. Each sector represents a category for the data. The area of each sector is proportional to the frequency of the category. The data presented in table 6 represents the educational attainment of residents of the United States, 25 years or older, 2017, based on data obtained from the US Census Bureau. The data are in thousands. Construct a pie chart of the data. Just like we have been doing, we're going to take a snapshot of this. So for me, it's Control-Shift-5. Oh, not yet. Control-Shift-5. Command Shift 5, not Control, sorry. Let's capture that. Bring it over to Excel. Let's get a new page. And from here, we're going to insert that table, take it from a file. And it should be this one here. Make sure the data looks good. All right, insert anyway. And now that we have that data, we could get a pie chart this time. So there's two ways that we could do this. We could either do it, the pie chart, we aren't going to have to follow the exact same rules that we have over here. We don't need the relative frequency, but it would be a good idea to do so. I'll kind of explain what they're talking about here. So remember a circle, if you guys remember from either elementary school, middle school, maybe even high school, a circle is 360 degrees. And all they're doing here is measuring out the sector. So how many degrees of that pie is going to each sector? So they would find the relative frequency, which remember, this is a proportion of the whole or a percentage of the whole. But whenever we do this on Excel, we don't really need all of that. So here we're going to remember this total is just the total. So we're not going to include that for our pie chart. Here, what we see here is the data insert. Ooh, lots of different choices. So I'm going to go with this one that looks like a pie. So pie chart, and we are going to hit this value here. And automatically it grabs all that data for us. So not a high school graduate, it's this one in blue. So that part right there. This orange part is high school diploma. So another thing that we could add in here is, let's see. So it would be the percentages. I don't have to do all that. But this is just a drawing of what these values would look like. All right, so that's more of like the aesthetic of everything. Oh, there we go. So the percentages involved with each of these. All right, so 12% would go to this blue part, which looks like not high school graduate. 27% would go to this orange part, 9% would go to this associates. So if you look at all of this, the highest one ends up being this 27, which is high school. And let's take a look over here. High school graduates, 60,000 versus the rest of them. The next leading one is going to be that 45,000, which isn't exactly the same thing, or it's considerably less than 60,000. So it makes up a smaller percentage. So 20% here, 20% here, which would be some college and also bachelor's degree. So bachelor's degree is this one in the lighter blue, and there you go. So that's how we could read these. Again, if you were to look at these graphs, you could kind of mess around with the look and everything of them. But there we go. Or would it be drawn? Yeah, so it would come from that data there. So again, we have all of these. They put the percentages and actually wrote all the stuff in here, but a little bit different. So that is it for section 2.1. If you guys have any questions, email me. Good luck.